questions about things you might have gotten stuck on last night, like maximums, minimums, zeros. The one topic that we didn't cover very far, but I was asking for you guys to try. Someone who thinks they have the maximum value of R, first of all, what is it? 20, good. How'd you get that though? Chart? You could have actually went through and graphed all sorts of different unit circle values and seen that 20 is the largest, but what could you have done simpler? Why plug in -1 and not +1? If you think about sign being in between 1 and -1, which value would maximize this function? Well, if I plug in 1, which would be 10 minus 10 is 0. Hey, that says 0, though. Okay, well, that's nice. A 0 is going to be when sign equals 1. But when sign equals -1, what's a -1 times a -10? Ah, a +10 plus a +10 is 20. What if I did sign equals to -√3/2 or -1/2 or oh, it's going to be cutting down the 10s. That's not going to work. Sign expands out and then goes back in, and as it does that, the largest it is 1, the smallest it goes, or the most negative it goes is -1. So we try both of them. At 1, we have zeros, and at -1, we have the max, which will end up being R equals 20. So we know R equals 20. When does 20 happen, though? What angles would sign be -1? 3 pi over 2. And that's if we're only looking between 0 and 2 pi. Couldn't it also be -3 pi over 2? Couldn't it also be, well, I guess you'd go all the way around and land on 3 pi over 2. So we could go ahead and add 2 pi in, right, to both of those. Forget him. Nice thing is that n can be positive or negative, so I'll get the negative ones at the same time. So yeah, there are lots of different places this can happen, but I think in most of your windows, check out your windows real fast. I don't think you were graphing beyond 0 to 2 pi, were you, most of you? Was it just 0 to 6.28 for the theta min, theta max? Okay, so then 3 pi over 2 would have been the only one that you would have seen. Now wait a minute, when you guys graphed it, did anybody even see 20? This is a 10 by 10 graph, doesn't it just stop there? Did anybody try to expand your window to see if you could see it any further? What if we go from -20 to 20? And remember, technically I would need to go 20 all the way around for my x mins and my x maxes, my y mins and my y maxes, because remember, it's circular now. So 20 can happen going in any direction. So I'm going to go ahead and make all of mine go 20s. I just saw the radius should be 20. So this is a good trick. I might have just stopped with 0 and been like, oh, that's all there is to my graph. Is there anything else to my graph? Oh. Whoops. Would some of you guys have just stopped there? Huh. Now, hold on. Does this look like a plus b sine of theta? Oh, I think it's a limacon one. So if you had memorized the limacon ones, you're like, no, that's a limacon, a plus b. I know it's a minus, but a plus or minus, b is a constant, could be positive, could be negative. It's a limacon. What helped me know how to make my window? Thinking about the max. Because then mathematically, I'm like, no, I should not be stopping only going out 10 everywhere. I should be stopping going out 20. Okay, so there we go. Now we have our shape, right? Now remember, if it was all funny and weird and whatnot, zoom standard, reset everything, maybe you're in degrees, radians, something weird, zoom standard. But then our max said, you better make everything 20. The x mins, the y mins, the x maxes, the y maxes, -20 to 20, -20 to 20. Now I see my shape. Okay, zeros. Should you guys have figured out that sine of theta equals 1 even without doing the whole sine is 1 or -1 just by setting everything equal to 0? Everything meaning the function? If you subtract 10, divide by -10, don't you get 1 equals sine of theta? And when will sine of theta equal 1 in your 0 to 2 pi that you guys are graphing? Yeah. Yes, there could be more places if we have it. Keep graphing, keep graphing. You'll just keep on tracing the same thing over and over again. But did you guys notice that as this thing graphed, now the hard thing is you can't make it graph again unless you go change something and then do it again. So we can make this like into a 9, then we can make it back into a 1 again. Now it's going to graph again. It's going out, it's going out. Ooh, pi over 2, and now it's going to pi. Now it's going to 3 pi over 2. Now it's going to 2 pi. This curve does not double back in on itself because the biggest r can be is 20. The smallest r can be is 0. So r never goes negative. And because r never goes negative, you never have an inner loop on this function when a equals b. If a equals b with an a plus b sine or cosine of theta, it'll never have an inner loop because it can never go negative. The smallest it can be is 0. So it's going to go hit the pole, and then it's going to ricochet back out. Do you know? Oh, no. I subtract 10, then I divide. So PEMDAS, I couldn't do the subtracting without considering the multiplying first, so this guy was stuck. Yeah, good question. Okay, number 21. His turn. I'm going to go ahead and change my window back to zoom standard. I'm going to go ahead and go back to my y equals and deselect this guy. Select that guy. But let's talk about him. Yes, you could just look in your calculator and be like, oh, I think I know what the maximum minimum is. But remember, we just saw that our calculator doesn't always give us quite enough information. Maybe we need to keep our wits about us. So what's the biggest cosine can be? Any cosine of 1 theta, 2 theta, 10 theta, 20 theta. Cosine still, anybody who's stuck inside can only go between 1 and -1. So if I'm trying to think of the maximum r, what happens if cosine, of 3 theta is equal to 1? What happens when cosine of 3 theta is equal to -1? If I plug in 1, isn't that just going to be r equals 4? And if I plug in -1, isn't that going to be r equals -4? Remember, -4 just means 4 in the opposite direction, but still, what's the farthest I'm going out no matter what direction I'm headed? 4. What's my maximum absolute value of r? 4. When does it happen? Well, all of these places. Well, guys, when's cosine 1? 0. And it's -1 at pi, so I have 0 pi, 2 pi. So I need cosine of, well, I'm already solving cosine inverse of both sides. So I'm thinking that 3 theta needs to equal 0 pi or 2 pi. Technically, I can keep on going all day long. Wonder why I'm keeping going all day long. Isn't 4 pi over 3, good. Isn't 4 pi over 3 too big? Sorry, not 4 pi over 3. I started to solve it. That's kind of lame. Colby just said you have to divide by 3. 3 pi is too big. No, it's not, because I'm dividing by 3 in a second. 4 pi is too big. No, it's not. I'm going to divide by 3. 5 pi is too big. No, it's not. 6 pi is too big. Okay, kind of, because it's 2 pi. So I'm going to divide by 3. So what am I going to get? All the pi over 3s and the axes. So man, this guy's hitting 4 a lot, right? Huh. He's hitting 4 there. He's hitting 4 here. He's hitting 4 here. He's hitting 4 there. He's hitting 4 there. And technically 2 pi also. How is he hitting 4 so many times? Okay, coming back. The maximum is going to go out is 4. It's going to go out to 4 a lot of times in your 0 to 2 pi. Let's come back over here, though. There's one more thing you were supposed to be finding. What's that? Setting everything equal to 0. This one's kind of easy. Divide by 4. You still just get 0. Wait a minute. Wait a minute. How do we get inside to get to the 3? What would I do over there to get to the 3 theta? Cosine inverse. So when does cosine equal 0? Pi over 2 and 3 pi over 2, right? It's going to hit at 90 and then 270. Or the x is 0 at 0 and 0 at... Or 1, 2, 3, that's sine. 3, 2, 1, that's cosine, starting at 1, ending at 0. That's at 90. Anyway. So I have 3 theta equals pi over 2, 3 pi over 2. Uh-oh, why am I still going? Because what am I going to do? When I divide by 3, how many more answers do I have? 3 times as many. So I need to keep going. 9 pi over 2, 11 pi over 2. And some of you already figured out when I divide by 3, don't I get sixths, right? So doesn't pi over 6 fit? Yep. Doesn't 3 pi over 6 fit? Oh, that's pi over 2, right? Doesn't 5 pi over 6 fit? And 7 pi over 6? And 3 pi over 2 when it's reduced, and 11 pi over 6? Ugh. Who is this guy that's hitting 0 so many times? He's going through the pole like over and over and over and over and going out to 4 over and over and over and over. Do you guys graph him? Yeah, he's a rose. With how many petals? 3. Only 3. I did not expect that. But pause and look. How many times in 0 to 2 pi does it go around the rose? It's through the pole 3 times, 4 times, 5 times, 6 times. Oh. Because it went through the rose 2 times, it's going to go to the maximum radius of 4, 1, 2, 3, 4, 5, 6 times. And it's going to go through the pole 1, 2, 3, 4, 5, 6. It's because it traces the same thing twice, not because there are 6 petals. Does that kind of make sense? Sort of? Dun, 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 dun. So, it's up to you. I'm going to leave this on the screen for just a little bit as you guys transition to get your homework spirals out. If you want this, you totally can write it down. If you're like, no, I think I got it. I mean, you just set equal to 0 and solve with the unit circle. And then for maximums, you just consider when sine of theta is 1, negative 1. Because remember, even if sine is a bigger negative number, it's going to need to extend out that way. So that's why we say maximum absolute value of r, the biggest number, positive or negative. So if you want to write this down, you definitely can. With other functions, I would say graph in function mode and find maximums, minimums. Sadly, if you guys did try to go, once again, it's like, oh, max min, that's a feature in our calculator. Dun, 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 dun. It fails in polar. So if you tried the second trace button, there was no max, there was no min. But if you take the polar equation, and if you put it in function mode, you can see the maximums and minimums. Now be careful. We're supposed to be thinking absolute value of r, so possibly an easier way of doing this, instead of thinking maximums, minimums, thinking of the negatives and the positives and which one's bigger, it might be easier to graph. Let's have an bar function in your calculator. You can graph absolute value of r and then just find the max. Meaning, I'm not going to ask you to find the maximum or minimum in honors pre-cal or in pre-cal in general of any besides one with sine or cosine. But I'm just letting you know, if there was a function without sine or cosine, you would graph it in function mode, graph the absolute value of it, and then you can find the maximum r that way. Ryan?
It was kind of a while ago with the example we were doing.
Okay.
But what was the point of like doing the first one with the 3 theta equals 0, and then we did it again, and then we used that second instance?
We didn't do 3 theta equal to 0. The first time we were trying to find the maximums, so that's when we were setting. Oh, did I not set it equal to 4? This one, we were finding the max values. We were finding when this equaled 1 and negative 1, which would make the r equal 4 and negative 4. We were finding when the r was 4 and negative 4. So we were finding values not setting equal to 0, setting equal to 1 and negative 1. This one we were setting equal to 0. So that's why we had two different sets of answers, because we were doing two different things. This one, when did it go through the pole? When did r equal 0? This one, when did it hit the outermost, which in our picture would be when it hit these outer edges. Does that make sense, the difference? Yeah.
And also when we're saying what it is, can we just say limaçon, or do we have to say what type of limaçon?
A limaçon will be a
So
limaçon.
we don't have to say like rose.
Well, a rose is a different shape. So there are roses, those are with the petals. There are limaçons that could have the snail, could have the inner loop, could have just the dimple, could have the convex, could have, what was the other one? Dimpled, convex, inner loop. There's one more name, I don't even remember. It's like the one that's kind of flattish. Limaçon is okay for those 4 types. Okay. Lemniscate is the infinity sign. Circle is a circle, line is a line. Okay, you guys good on this? If not, take a picture of it. I'm going to go ahead and take it down. If you want it, that's totally fine. Just grab a picture of it, or someone in your group, have them grab a picture of it. You can keep writing it down, because I'm going to transition over to homework answers, okay? Got it? Okay. And then, Ryan, what you were asking, these are the limaçons, but these are the limaçons. This is almost like a circle, but it's a little dimpled, and it still has an a plus b. So anytime you have an a plus or minus, b cosine or sine, it'll always be a limaçon. These are all roses whenever you have some sort of sine or cosine with a theta or a 2 theta, 3 theta, 4 theta. I shouldn't say a theta, but with a 2, a 3, or 4, or 5. Those are all roses. And then we have circles that are just 1 theta, because it's like one big old petal, perfect petal. Then we have lemniscates. Okay? Those are in your notes if you guys want them. I'm just not giving you time to specifically write them all down. Oh, hey, I have it ready already. Here you go. Boop, boop. Number 4 is a circle. Number 6 is a cardioid. Number 8 is a cardioid. Ooh, a cardioid is a special name. That was the wrong, yeah, the dimpled was the one that just kind of went in a little bit. The cardioid is the heart that goes all the way into the pole. There is that special one, Ryan. The cardioid is a limaçon that goes all the way into the pole, has that little, like a heart.
Cardiac part.
Exactly. Whoa. Remember, the even ones double the petals, the odd ones, well, that's a plus or minus. Are there any odd ones? The odd ones stay the same, whereas the even ones, wherever they are, double. The lemniscate has a little squared guy. The lemniscate has a little squared. And if there is only one petal, he's going to be a circle. Number 14 was asking about symmetries. So what ended up happening is that it only had symmetry. I mean, it went through all the tests. It only had polar axis symmetry. Yes. It only had polar axis symmetry. Pole failed, and then pi over 2 failed. You guys ready for the next page? Okay. Number 22. You guys see how they checked when sine was 1 and minus 1, and then they went through and found all theirs? And the in-between step would have been 2 theta equals pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and dividing by 2 to get the fourths. So that's very similar to what we just did. The zeros. Wait, those were the maximums. Hold on. What else are they asking for? Oh, the zeros. Here we go. The zeros are going to be at 0, pi, 2 pi, but we have to set our 2 theta equal to that. It'd be 2 theta equals 0, pi, 2 pi, 3 pi. Divide by 2. But there again, kiddos, if you made a table and you were just plugging in unit circle values, I bet you would have figured out that at pi over 4, you would have gotten to those 3s and negative 3s, and at pi over 2s, you would have gotten to the zeros. So it is valid to, like, if you just like making the tables and not having to do all the crazy equation work, that is valid. You can try that. '38, they go through all the symmetries. To be honest, maybe it's good to know the symmetries, that it does have pi over 2 symmetry. Couldn't you have used our trig, though? What trig function was inside? Sine. And sine's the same in all students, in quadrants 1 and 2. Oh, pi over 2 symmetry. You could have made a table with some of the values and then been able to copy it on the other side. You were able to plug in sine is 1. When sine is 1, the highest out you needed to go was 9, so you need to have your graph go all the way to 9. I think they were counting by 2s, 2, 4, 6, 8, 9, yeah. So the maximum R was 9. It hits zeros at 7 pi over 6 and 11 pi over 6 if you guys graph. But if you just did your table, you should have also gotten the limaçon. Now, those of you guys that did a table, if you did a table, what makes the inner loop again? What makes the inner loop? Well, you do hit 0 at, this one is going to be at -1/2. 7 pi over 6, when R goes negative. So at 7 pi over 6 is going to hit 0. So R is going to get bigger, 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 bigger to 9, smaller, 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 smaller to 0. Then it's going to go negative, negative. So when it should be going out towards like 5 pi over 4 and 4 pi over 3 and 3 pi over 2, and it should be going out, guess what it's doing instead? It's going in. When it should be going out, it's going in. It has negative r's, negative r's, negative r's, negative r's, until it hits 0 again. And then what's it start doing? Going out again. Anyway, negative r's make the inner loop. And that can be seen here because if sine is -1, can't r go negative 3 minus 6? Oh yeah, r can totally go negative. And the one that we did in class, 10 plus 10 sine, there was no way for r to go negative. The smallest it could go is 10 minus 10, 0. Last but not least, this one was kind of a cool, can you use your graphing calculator? Did you realize to get your whole shape you had to go between 0 and 4 pi? 2 pi wouldn't have cut it. You wouldn't have had the whole thing. Part of the reason is right here because of the argument with the 5/2 theta. But then if you had had your thetas, you just would have had to change your theta step to be a little more, and you could have had it keep graphing like, oh, now I got my shape. It was a cool one that like doubled in on itself a little bit. Were there any more evens? Is that it, 62? Okay, any questions on 10.8 that we need to go over? Yeah.
We were just like looking for symmetry. Like,
do you want to look at an even one?
14, yeah, 14.
Okay.
Like what was it for that? The same that it doesn't change the original equation, divided by negative because it's all going to be.
You have to remember the properties of cosine and sine as to who's even, who's odd. I think that's probably the easiest way. Because in a lot of these, you're plugging in negative thetas, right? And having to figure out how to make that jump. And so that yesterday, it was quick when I wrote it. But for the symmetries, I'm just getting back, David, so I can show you. Remember, when you plug a negative into sine, it flips. Think of it this way. Sine goes like this, right? So if I go backwards, if I go a negative theta, I'm going to go down or opposite, whereas a positive theta goes up. So for sine, if I plug in a negative theta, it's going to be opposite going positive. But for cosine, think about him. If I copy on the other side, I mean, pretend it. I can't do that with my thumbs. Ugh. But if I'm here, if I go negative theta, I'm doing the exact same thing. So if I plug in a negative, it's the same as the positive. So then this is the jump that they were making when they plugged in for those tests. So coming back here to number, wherever he is, 14. ¿Dónde está? Aquí. When they plugged in the negative to cosine, they're like, oh, he stays the same. And that's how they were able to say, hey, if you plug in a negative r and a negative theta, does it stay the same? Well, this side does, but that side doesn't. It's not. Does that make sense? It's not the same as the original. And then this jump stays the same. Oh, that's perfect because R didn't change. That's the polar axis. And then this one, when R changes and that one doesn't, it's like, no, it's different from the original. So you're trying to see, can it match with the original? But remember my hint, too. If there's only a cosine, what kind of symmetry should it display? Polar axis. If there's only a sine, pi over 2. Because of all students and because of all students take calculus. Cosine is the same all in calculus. Sine is the same all in students. Little tricks. Carl.
Was number 38
Yes. Which limacon would be enough as far as for me. The only special limacon is the one that goes to the pole. He's called a cardioid, like a heart.
But he got it was like tilted to the right. So grab that and shift it to the right.
Then something went wrong when you plugged it in your calculator. Okay. Or maybe when you're plugging in, because it should go through the pole, it should go through 0. So maybe you were graphing it fast. But no, it should have gone through. Oh, that's a good thing, though. So something funny happened. When we have some work time, we can look at your work and see what happened. Kiddos, we're at the end of chapter 10. This is 10 point. There's a 10.9? Yeah, no, we're skipping 10.9. 10.9 is not in the homework page. It's not in our whatever. I don't even remember what the section is. I just skip it every year. What was 10.9? Probably applying. Oh. Doing like word problems with ellipses and stuff like that.
Let's not do that.
It's okay. At some point in time, you can build on our basic polar stuff to do that. All right, guys. We still have about 10 minutes. So let's use this time well because we do have a review due tomorrow. Let's go ahead and get it written down. I'm going to go ahead and throw it on the screen. That way you guys can start working on it. Wait, why doesn't it start until number 53? Oh, it's only on 10, 6, 10, 7, 10, 8, yeah? All right, let me pull it up on the screen. That way you guys don't have to come rushing up unless you really want to. Starting at number 53. There you go. Boop.